So we'll start with aldehydes and ketones. Aldehydes and ketones. Now, functional groups, when we talk about aldehydes and ketones, we will just generally introduce the keto group. C double bond O, C double bond O with C double bond O with R and R dash. So this is a carbonyl group. This is a carbonyl group. Now when R equals R and R dash, both are alkyl groups. Alkyl or aryl or any other group, you call it as ketone. That is ketone. If R equals H, R equals what? Voice into the Can you hear all of you? Can you hear me? Didn't I not able to hear? What about others? Can you hear me?
കേൾക്കുന്നുണ്ട്.
No. Okay. Maybe something is wrong with her connection. Just give a message to her. Okay. Now, R equals H and R dash equals alkyl group. That you call as aldehyde. Aldehyde. Okay. That means an aldehyde is, you can write the aldehyde as RCHO. Now, R equals OH. Then all the R dash are alkyl in further discussion. Okay. R dash is alkyl. R equals OH. You call it as carboxylic acid. Carboxylic acid. So it is R C double bond O OH. If R equals OCH3 or OR dash, then you call it as ester. R C O O R dash, ester. If R equals NH2, you call it as amide. R CONH2. Okay, amide, ester, then what do you have? Yeah, R equals halogen or say chlorine, bromine. You call it as acid chloride or acid halide. See, these are the common functional group. These are the common functional group arising out of the C double bond O. Okay. Now, let us look at the individual compounds. We have simple molecules. The aldehyde which contain only one carbon. Aldehyde which contain only one carbon. C. Both R will be H. This is called a formaldehyde or formaldehyde. And we call this as methanol. IUPAC name is methanol. That means any name ending with AL is aldehyde. Okay, the name which ends in AL. AL stand for CHO group. Okay, now, so this compound is now replace one of them with CH3. This is H. This to call as ethanol. Or common name is acetaldehyde. Acetaldehyde. That's a common name. Then we have compounds which are aromatic, very common compounds which are very pure, widely used in industry. Aromatic aldehyde, you call it as benzaldehyde. Benzaldehyde. Again, which we call as this is actually accepted by IUPAC. This itself is a IUPAC name. Benzaldehyde. Now once we convert this benzene ring and aldehyde hydrogen is replaced by CH3, it becomes a ketone. Okay, alkyl group and aryl group. You call it as the common name of this is acetophenone. Acetophenone. So the common phenone. O-N-E. O-N-E stand for ketone. If the name is ending in O-N-E, you call it as a ketone. A keto group. That is this group. With both the side alkyl group. Okay, alkyl or aryl. So this is acetophenone. And suppose I have got both the side benzene ring. Both the side, if it is benzene ring, you got as benzophenone. Benzophenone. Okay, so this bens stand for one benzyl one phenyl ring, and the other PHEN stand for the second phenyl ring. Okay, acid stand for the CS3 group, and PHEN stand for the phenyl ring. Right. So this is a nomenclature and structure of some of the very commonly used aldehydes and ketones. Let us see what are the methods of preparation of aldehydes and ketones. Okay. Preparation methods. I think we have already studied a few preparation methods. You can prepare the aldehydes and ketones from alcohols. Alcohols we have seen on oxidation. Oxidation of alcohol will give you aldehyde or ketone. That will give you RCHO. But unfortunately, this is very difficult to control. In the sense, this will get further oxidation to carboxylic acid. It is very difficult to stop at the aldehydic stage. This will get further oxidized into carboxylic acid. Okay, so a careful reaction condition is required for uh, oxidation of this. For example, if you are taking CH3, CH2, CH, CH2OH, propanol, N-propanol. You can oxidize this. I remember I was doing this a lot of time during my research work. I was doing this oxidation reaction many times using potassium dichromate, K2Cr2O7. Sorry, K2Cr2O7. A beautiful reaction. It's a colorful reaction, I should say, because potassium dichromate is having a very beautiful, good orange color, sulfuric acid. Okay, and this will get oxidized into aldehyde CH3, CH2, CHO. Propionaldehyde. Propionaldehyde. The moment you see the propionaldehyde is having some boiling point, something like how much it is? 70, 85 or something. The boiling point is something like 85 degrees Celsius. Now, what you should do is, if you have to take the flask, actually we used to take a 3-neck flask. One neck from here and one neck from here. 3-neck. Okay. And then we have to keep a condenser here. All big stuff. Okay. Now the reaction mixture is taken and heated. The propionaldehyde, you are heating it above 100 degrees Celsius. This contains dichromate solution Na2Cr2O7. And from here you are adding drop by drop propanol. Propanol is added drop by drop. sulfuric acid and sodium dichromate is initially taken into the flask. So the moment the propanol is added, it starts oxidizing, and immediately the moment this is formed, the moment your aldehyde is formed, it gets evaporated and enters here into the condenser and condenses here, goes out. Okay. If it is remaining inside the reaction mixture, what happens is it will be converted into corresponding carboxylic acid. So there was a very interesting setup here uh, with a long condenser, two condensers and cooling water. Hot water will be used for cooling to this side. I don't want to go into details of that. Okay, there was a specific arrangement of stopping this reaction at this stage. That is what is important. Okay, you should not go to further carboxylic acid. Okay, now, so this is how you prepare aldehyde from alcohols. Right. Now, there are certain reasons which are very specific only up to which will stop the oxidation up to aldehyde. Say, for example, uh, a reagent called pyridinium chlorochromate. Pyridinium chlorochromate, one second. So, somebody is now getting connections. Some of you are finding it difficult to get connections. You know that. Okay. Right. Yeah. So the compound is pyridinium chlorochromate. Chlorochromate. In short, we say PCC. Okay. PCC is a reagent which is used to convert an alcohol or CH2OH to specifically RCHO. And there will be no further oxidation. Remember that. That is the most important. It will not get further oxidized. Right? So that is a common reagent used for this. And also you can use. Another example you can use like this here, CH2 double bond. CH. CH2OH. If you want to oxidize this, you will get this compound, CH2, double bond CH, CH2, sorry, CHO, CHO. Suppose you are using sulfuric acid and dichromate here, this side also will get oxidized. Okay, that is here this double bonded group is not getting affected by the oxidation. Okay, if you are using dichromate or potassium permanganate, this part will get oxidized. So that is the importance of this PCC, pyridinium chlorochromate. Sorry about the structure of this molecule. Don't worry about the structure of the molecule. Okay. Now, so that is uh, oxidation of alcohols. Suppose you are using a secondary alcohol. Example CS3, C double bond, sorry, CH, CH3, CHOH. This is a secondary alcohol. We have seen this. If we use a secondary alcohol, we will get ketone. Oh, we will get ketone. I was going to write this product. CH3, C double bond CH3. We have studied this before. We'll get a ketone. You can use any of the oxidizing agent for this. Potassium mercury, chromium trioxide, all this. Even PCC will do the same job. PCC will also do the same job. Again, if we have a structure, look at this one. Here you require PCC only. The double bond will remain as such, and your OH will be converted to ketone. So this is the oxidation. This is the oxidation. Now another method is again a similar oxidation reaction. A similar oxidation reaction is instead of taking an oxygen, any oxidizing agent, instead of taking an oxidizing agent, you can do you can have a different approach. Here, RCH2OH. Let me write the CH2OH in a different way. Look here, I will write one H here and one H here. Then OH I am writing here. Now see, you can convert this in a very simple method. Very easy to write on the paper. Look here. This is nothing but oxidation. Removal of hydrogen is also an oxidation. Okay, one second. Let me make it a little more clear. I'll put the hydrogen on the top so that you can avoid confusion. So let me put the hydrogen here, and I'm making the double bond on this side, plus H2. This reaction we will call as dehydrogenation. Dehydrogenation. That is also a very good method of converting on a large scale normally. So this can be achieved by heating with copper. Only heat with copper at 573 Kelvin. 573 Kelvin. So 273, 373, 4. So that means approximately 300 degrees Celsius. The temperature is around 300 degrees Celsius. So you can convert ethanol. You can convert ethanol into acetaldehyde by this method. So that is the second method of making aldehyde and ketone. So that now let us look at. We have many other methods of making aldehydes and ketones. Quite a few methods. Maybe a couple of methods more we will see. Let me just check. Just a couple of other sources again we have to study. But if you let me see one second. Oxidation reaction, if you look at addition reactions, yes. One second. Yes, let me see. Yeah, you can prepare aromatic aldehydes. Yeah, this is something which we have studied again. How will you convert this compound into this compound? We have studied this aromatic aldehyde or ketone. These are some of the specific aldehydes and ketones. So this can be done by using CS3 COCl, acetyl chloride, in presence of aluminum chloride. And you call this as Friedel-Crafts reaction, which you have studied. So that is a method of preparing specific aldehyde. Okay. Now, here is another compound. Suppose I want to prepare this compound. I want to prepare this compound, CS3. I can use this. You can start with a alkyne. Alkyne 1, 2, 3, 4, 5. How many carbons here? 1, 2, 3, 4, 5, 6, and 7. Yes, see here. Okay. This aldehyde, this alkyne, this is 1 hexyne. What's the reagent? The reagent is hydrolysis. H3O plus in presence of acid and a little amount of mercuric sulfate, HgSO4. Mercuric sulfate. Okay. You will get a ketone. Okay. Now, if you do the same thing, if you do a borohydride, hydroboration and oxidation, hydroboration. Hydroboration means adding with BH3, reacting with BH3, that is meant by hydroboration. First step. And second step is oxidation. You will get an aldehyde. Look at the beauty of these two reactions. I just remove this one. Why it is beautiful is see here. Something very interesting is see here. This terminal carbon becomes carbonyl group. See, in this reaction, if you do hydroboration oxidation, you get aldehyde. That means this carbon becomes CO group, the last carbon. Okay, in hydrolysis, the central carbon this carbon will become CO2. Okay, so these are very specific reactions where you can achieve things which you feel impossible. That is things which are impossible are being done. Right. Now let us look at the chemical properties of aldehydes and ketones. Chemical properties of aldehydes and ketones. What are the chemical properties? Already we have seen oxidation reaction. Oxidation of aldehydes. Oxidation of aldehydes. CH3, CH2, CHO. This will give you on oxidation carboxylic acid. COOH. Here. You can use sodium dichromate. I told you, you cannot stop at this. Na2Cr2O7 and sulfuric acid. So that is it forms. So that is the case with the aldehyde, but you cannot do the same job with the ketone. Ketones will not be converted into uh, carboxylic acid. Ketones will not be converted into carboxylic acid. Okay. So aldehyde will be converted into carboxylic acid. So that is oxidation. Then we have many other reactions like nucleophilic addition reactions. Nucleophilic addition reaction. Now, what is meant by addition reaction? We know what is addition reaction. A double bond is converted into a single bonded compound. Okay, so here, nucleophilic addition means we have a double bonded oxygen. We have a double bonded oxygen. And then we can convert it into a single bonded oxygen with one group here and one group here. Okay, some group here. Normally this will be H and this will be the nucleophile. Right. So you can do this addition reaction under two conditions. One, under acidic condition or under basic condition. First we'll see the under basic condition. Basic condition. Addition reaction can be done under basic condition. Now under basic condition, what happens? What happens under basic condition? Now, in basic condition, the nucleophile will be directly attacking nucleophile directly attack your carbonyl, and this opens up onto this side, right? So what you get is you have your R, R1 and R. You have the nucleophile on this side attached, and this form O minus. So this is under basic condition. Now after the reaction is over, you add an acid into this. You add an acid. Acid will supply a proton that will be taken up by this compound, and you will get the product OH and nucleophile. Now let us see what happens if it is done under acidic condition. So the second condition is acidic condition. Acidic. Here the mechanism is slightly different. First, the lone pair of electron on this carbonyl group is attacking the acid. See, the medium is acidic, means H plus is very reactive. So, see, what is the result of this? We have double bond with a positive charge, one lone pair of electron is remaining, and you get, see here, NOH. Now, once this has happened, now your nucleophile is attacking. The nucleophile, okay, which will be containing a proton, is attacking this carbon. Right. Remember nucleophile, why it is acidic condition. Remember that. And therefore nucleophile will not be having a negative charge. Nucleophile